All right, for today's lesson, I need you to turn to page 201. Yay, we made it to page over 200. And today's lesson is about learning about horizontal asymptotes. So horizontal is a flat line, right, like the horizon where the sun comes up. So we're going to learn about these flat line boundaries. So an asymptote is a boundary. It says, decide if each of these equations is true or false for x values that do not result in a denominator of 0. Be prepared to explain the reasoning. So I want you to plug some numbers in here. Don't use 0 because it says not to. And sometimes when you use 1, it's going to cause an issue. So try 2. So put 2 in for x and see if those are the same. And then down here, put 2 in for x and see if they're the same. So try and figure out if these are okay equations. All right, let's see what you did. 2 plus 7 over 2, is that equal to, that's the question, 1 plus 7 over 2? When you have these rational functions, which is the second part of this unit, you need to use parentheses in the numerator and the denominator, the top and the bottom. So this has to be added together first and then divided by 2. So there's invisible parentheses there. And if you're going to type it in the calculator, you'd have to type it in that way too. So here we go. I'll type it in the calculator wrong and right. So if I do 2 plus 7 divided by 2, that would be the wrong way to type into the calculator. All right? The answer is not 5.5. So you're going to do parentheses 2 plus 7, because you have to force that to happen first, divided by 2 is 4.5. And then over here, if we do 1 plus 7 divided by 2, I also get 4.5. So this one is true. All right. And then this one here is a definite dud, right? Because if you do 2 over 2 plus 7, that's only 2 over 9, right? And then if you put 2 into this side, you get 1 plus 2 sevenths, which would be 1 2/7. Well, 1 2/7 is not 2/9. So this one is definitely false. So what's going on here? We want to see how these are the same. And they're the same because of division. So here's the lesson in a nutshell. So x plus 7 over x. What we're going to do to get this to be the same is we're going to distribute the division. So there's invisible parentheses here. So you're going to distribute the division. So you're going to do x divides into x. So I write x over x. Write that with me. X over x. And then you're going to distribute, you're going to divide that by 7. So you're going to write 7 over x. Then x divided by x, or the same thing divided by the same thing, is 1. So we write 1 plus 7 over x. And that's why they're the same, because you're distributing the division. Okay, next page. We are going to sell some books, but they have to be printed first. So it says, let C be a function, let C is cost, be a function that gives the average cost per book, C of x. So x is your number of books. So this is x down here. X is your number of books. And then this is C over here. It's your cost as your cost per book. So C is over here, cost, and then number of books printed is down here. Okay. When printing them on an online store, X copies of a self-published paperback book. Here is the graph. So what is the approximate cost per book when 50 books are published? So we're going to go to 50, right? We're going to go up here, and it's about, what, $6 and something? So we want to know C of 50 is approximately 640. Okay, and then we're going to do C of 100. So we're going to see what approximately. So we go to 100, and it's what, 525? 525. Okay, if we want to know the exact answer, we can type it in. So let's type it in. So we're going to do make sure we use parentheses here. Again, there's invisible parentheses. So we got to put the parentheses in the calculator to calculate this out. So we're going to go left parenthesis 120 plus 4 times 50, close the parentheses, divided by x, which is 50. Oh my gosh, I got it exactly right. Then we'll do the same thing again. Parenthesis 120 plus 4 times 100, close the parentheses, divided by 100. So we type that in, and we get 5. So it's really 5.2. So right here it's 100, comma 5.2. So $5.20, and then this one was 50, comma 640. Okay, the author plans to charge $8 per book. About how many should be printed to make a profit? So we want to make $8 per book. How many should be printed to make a profit? So we're going to do 8 is equal to 120 plus 4x divided by x. So we're going to solve this equation, and this is a proportion. So to solve a proportion, we cross multiply. So we're going to do 8 times x would be 8x, and then this thing times 1 would be 12 plus 4x. So we cross multiply to solve a proportion. So now it looks like this, looks like an algebra 1 equation. So we got to get the x's on the same side. So how are we going to get the x's on the same side of the equation? We're going to, that's right, subtract the 4x over. And then we end up with 4x is equal to 120. The last step would be to divide by 4. So x is 30 books. So it's right here. 30 books would be $8 a book. For what value C of x when x is a half, how does this relate to the context? Well, this would be x is a half, so we're only going to print a half a book. Doesn't really make sense, does it? Right, so this says we're only printing a half a book. So what's the value of C of x when x is a half? So we're going to do 120 plus 4 times 1/2 divided by 1/2. Okay, so we're going to type this into the calculator, which we've already done a few times, right? So we do 120 plus 4 times 0.5, close the parentheses, divided by 0.5. So instead of messing with a fraction, that's an easy fraction, so I just did that. $244. So it costs $244 to print a half a book. That's kind of silly, right? But that's what it means. So what's the end behavior of the function say about the context? So if x is large, right? So it's like inverse relationship. If x is large, then it's costs less per book. So costs less per book. If x is small, then it costs more per book. Okay, so let me clean that up a little bit. Okay, so if x is large, it costs less per book. If x is small, it costs more per book. So do you see where it's leveling off here? It's going to level off at $4. So y equals 4, or cost is equal to $4. That's your horizontal asymptote. That's where it levels off. So where is this 4 coming from? Well, let's look right here. So we're going to take 120 plus 4x, and we're going to divide it by x. So we're going to do what we did on the other page. So we're going to take 120 divided by x plus 4x over x. Then we get 120 over x plus 4. That's where the 4 is coming from. The 4 is your horizontal asymptote. Because as x gets larger and larger and larger, 120 divided by a million or 120 divided by a billion is basically no money. So this is heading to 0, right? This is getting smaller and smaller and smaller. So what's left over? The 4. And that's where it levels off. It levels off at 4. So this is emphasized in the next page, where we're going to take all of these graphs and match them with all of these equations. But before we do that, let's find the equations that are the same. All right, so let's find the equations that are the same. So here we go. The following equations are the same. So we look here, and we're going to make them all look like this. So here's the first one. We're going to do 1 over x plus 4x over x. That would be 1 over x plus 4. So this is going to level off at 4. So we need to find what one that's like. So that one is like, so C is like H. So H and C are the same. Okay, so you can see that those are the same. Now we go to the next one. So we're going to divide. We get x over x is equal to 4 over x. Not equal to, plus 4 over x. So we got x over x, 4 over x equals 1 plus 4 over x. So that one is the same as which one? This one down here, G. And then we go to the next one. 1 over x minus 4x over x is equal to 1 over x minus 4. Okay, so oh, that's like B. So then F is like B. Okay, and then the last one here is, oh, oops, E is like B. E and B are the same. There we go. So that means these are the same. F and A are the same. So let's show that those are the same. So we got 4 over x minus x over x is equal to 4 over x minus 1, because x divided by x is 1. There we go. So what does this mean? The blue ones have this minus 1 here, so they're going to level off at negative 1. So the blue one is going to level off at negative 1, because that's the horizontal asymptote. Okay, because when you have 4 over a huge number, or 8 or 4 over, you know, a really big number, it's basically 0. So negative 1, right, is where it levels off. So we go back here, and right here, y equals negative 1. That's where it's leveling off. So that would be the blue one. Okay, then we go to the next one. Sorry about all this page flipping. It's a bad page flip. So the orange one, it levels off at negative 4, because 1 over 10, 1 over a million, right, gets closer and closer to 0, so it levels off at negative 4. So we go back here. Which one levels off at negative 4? That would be B. And negative 4 is the orange one. All right. And then the next one, green, right? Positive 4 levels off at positive 4. Green is positive 4, and that's this one. That's A. And then, of course, the last one has to be the yellow one. The yellow one says that it levels off at 1. Does the yellow one level off at 1? Yep, levels off at 1, because 4 over 10 would be, and 4 over a million would be basically 0, so it levels off at 1. So here are the colors again, right? Green, orange, yellow, and blue match up with the 4 colors here. All right. Now we're going to look at the orange page, because we'll get the summary here of what the horizontal asymptote is. So now I'm on this page here, which is page 206. Page 206. Page 206. So there it is, right? And then what do? Distribute the division. And then we get x over x is 3. So 1 over 100 is basically like 0, but if you put some more zeros there, 1 over 100,000 is basically 0. 1 over 100 million is basically 0, right? So basically this is insignificant, and that 3 right there shows you where it levels off. So it says here, as x gets larger and larger, right? As it gets larger and larger, then it gets closer and closer to 3, where it levels off, the horizontal asymptote. And that's how you spell all that, the horizontal asymptote. And now you're ready for the purple page.